not go in detail on the other mods, but I guess if it's okay with you, we can start with the remote access, I guess. Does that sound good, Dr. Robin?
Very good. Very good.
Okay, great. So okay. So what we're gonna do. So here is these are several samples that I prepared that we're gonna see today. So you can see over here, this is the vacuum that we have in the cell chamber, which is the 10 to the minus 7, and in the column that it is 10 to the minus 10. So we're in the right vacuum range, and if we go to the electron now, we see that it's off. There's no oscillation voltage here. So we're gonna turn this on. And we will get the images soon enough. But while this happens, and this is going to talk a bit, one of the first samples that we'll see, and I'm gonna stop sharing the screen for a moment so you guys can see me. We're gonna look at butterfly wings. So this is a butterfly. This is called it's from the Morpho family, right? So you can see from the back to from the bottom, this butterfly has brown. Can you guys see the butterfly again? Okay, so it has brown wings, right? And in the other side on the top part, depending on the angle of the light, you can see it gets to a very shiny blue, right? And there's no pigmentation in this. This is only, it depends on the, it uses the bottom parts for camouflage and the top part for like signaling other butterflies. But there's no blue pigmentation in this, and it's a very, very intense blue. So why is this happening, right? So if we look, okay, so if I share the screen again, okay. Can you guys see the microscope? You can see the microscope again, right? Okay. So if we take a look at the butterfly wings with an optical microscope, we see that it has these scales over here, right? And this is, this is not it's a image from, I think this is Yahoo, right? But there are many, many pictures of this butterfly, but you cannot see any of these, you just see these scales, right? But we'll see with the SCM what happens when we go to the nanoscale. So now that we're here, okay, electron gun is okay. So now I'm gonna go and activate the in-lens detector for secondary electrons. And we're gonna, okay, we don't see much now, but I'm gonna try to focus this thing. Okay. Okay, so maybe if we go somewhere in here, we can see something. Okay, do you see the scales? Okay, so these are the same scales that from that picture, right? But what happens with this, if we start zooming in, right, you realize that they're not just simple scales, but they have, okay, let me get some more contrast on this and try to focus a bit better. We keep increasing. You see that there's some kind of pattern in here, right? Can you see that? Trying to get the right focus. Okay, let me see if I can improve the image. Okay, that looks better, right? Okay. So in here, we see this, oops. We see the structure in the wing, right? And we can see that it's very repetitive. These are the distance between these ridges is very homogeneous, right? It's around 2 micron, 1.9. So does this give you any idea what happens? So what we have is that because of this repetitive structure, this works as a diffraction rate, and the light that it's reflected off the butterfly at a specific wavelength, and depending on the angle of the incident light, and depending on this spacing, in this case, at this exactly separation, this rating, that's why we're getting a very strong blue coloration from butterflies. And this, for example, this can be used for all kinds of, for chemosensing applications, for gas detection, to make synthetic structures inspired on this structural correlation. Does it make sense, guys? Okay, so what we can do now, if we have a volunteer, I'm going to give you control of the SEM, and you can inspect some other regions, and see other scales, and see how this how homogeneous and how cool these butterflies are. So do we have a volunteer?